My dear friends, welcome to Raja classes on applied data science with Python. This is lecture number 132. In this lecture, we will try to understand sampling distribution. First, we will define what is sampling distribution. Before understanding sampling distribution, first let me define what is sampling. Sampling is the selection of a subset of individuals from within a statistical population to estimate the characteristics of the whole population. Let me write like this. What is this sample? I can say it is subset of individuals. Subset of individuals from where? This subset of individuals from from population. Let me say from population. Why do we need this subset of population? What is the intention? Intention is to estimate. What I have to do? To estimate the characteristics. Whose characteristics? To estimate the characteristics of population. That is sampling. I have to estimate the characteristics of the population. Isn't it? Distribution means how this samples distributed. Roughly I can say in appropriate definition is, I can say like this: sampling distribution is a distribution of all of the possible values of a statistic for a given size sample selected from a population. You need not worry about this definition. We will try to understand this sampling distribution with one numerical example so that you can understand. Time being, let me proceed further. Just let me explain types of sampling distributions. There are basically three types of sampling distributions. Sampling distribution of sample mean. You can collect from sample mean. You can make use sample proportion. You can make use sample variance. In this lecture, we will try to understand sampling distribution of sample mean. What is this sampling distribution of sample mean? Just observe this particular diagram. What it says, it is simple. Suppose, assume that there is a population. There are 4 people in the population A, B, C, D. Isn't it? There are 4 people in our population. Random variable X is age of individuals. Here X is a random variable. This indicates age of individuals. Value of X may be 18, 20, 22, 24 years. Isn't it? This is the description of our population. Now what will we do? Just we will try to understand summary measures for the population distribution. My first summary measure is population mean. This is mu. How will I get this population mean? What are the members in my population? Age of first person is 18, second person 20, 22, 24. My mu is sigma xi bar by n. Sigma xi bar means just add, n means population size, that is 21. That is first summary measure. My second summary measure is standard deviation, that is sigma xi. How can I calculate? Under root of xi means this is x1, this is x2, this is x3, this is x4. I equal to 1 to 4. x1 minus mu whole square means 18 minus mu is 21 whole square plus, what about x2? Plus 20 minus 21 whole square plus 22 minus 21 whole square plus 24 minus 21 whole square. Just take this one, isn't it? Under root of what does it mean? By capital N. What is my capital N? Population size is 4. Just to simplify this, you will get one more measure about population. This is population standard deviation, isn't it? Now, let me calculate probability of each member. What are the members of my population? 18, 20, 22, 24. How am I plotting this? Just see. Let me calculate like this. What is my, I'm taking ages on x-axis. Just see. 18, A age, B percentage 20, C percentage 22, D percentage 24. Let me calculate probability for P of x equal to 18. How many favorable cases are there? One favorable case. How many total cases? 4. 1 by 4 means it is 0.25. In similar manner, what is the probability of x equal to 20? Favorable case 1, total 4. 1 by 4, that is 0.25. In that manner, I can calculate probability of 18, 20, 24. If you calculate probability, what am I getting? I am getting 1 by 4, that is 0.25. I can say that probability is same, uniform for all values of this age, whether it is 18, 20 or 22, 24, probability is same. Therefore, I can say this is following uniform distribution. Isn't it? Chances of selecting each person from the population or probability for selecting each person from population is 0.25. This is about our what? Our population. Now we will try to understand about sample. Suppose if you consider all possible samples of size small n equal to 2, what does it mean? Small n equal to, here I can say like this, I'm going to collect a sample. Small n indicate sample of size 2. We are going to select 2 people with replacement. This is important. I am collecting a sample of size 2 with replacement. With replacement, isn't it? There is a formula. What are the possible number of samples? Capital N power n. Here my population size is 4, sample size is 2. 4 square means I will get 16 possible samples. How will I get that 16 possible samples? Just write population here, 18, 20, 22, 24. This just write population here, 18, 20, 24. Now just collect samples of size 2. 18 comma 18, this is one sample. 18, 20, this is another sample. 18, 22, another sample. 18, 24, another sample, till 24 to 24. Totally, how many possible samples are there? There are 16 possible samples. Now, if you find the mean of this, the right side picture, just see this picture, just calculate mean. How can I calculate mean? 18 plus 18, 36 by 2, that is this one. 18 plus 20, 38 by 2, 19. 18 plus 22, 40 by 2, 20. 24 plus 24, 48 by 2, 24. Means I can say these are the 16 sample means, isn't it? How many samples we have got? We have got 16 samples of size 2. Now we calculated mean of all those 16 samples. When you plot this mean, what's happening? That mean of this sample following normal distribution. Previously, just plot this one, what's happening? If you plot this one, just see. Just observe carefully. 16 sample means, and there I am taking on x-axis, I am taking sample means. What are the sample means? 18, 19, 20, 21, 22, 23, 24. Just see, 18, 19, 21, 20, 20, 21, 22. Corresponding probability. Just I am calculating corresponding probabilities on y-axis. This is x bar, this is px bar. These are the 16 sample means. Just I am plotting this one. If I plot, what am I getting? I am getting normal distribution. If you compare this particular graph with previous graph, if I take single sample size 1, that means if I take population as it is, we were getting uniform distribution. Now it's no longer uniform distribution. Now it is just normal distribution. Previously, when you take only one sample, when you plot it, you are getting uniform distribution. When you increase the sample size from 1 to 2, what's happening? You are getting normal distribution. It is no longer uniform distribution. Now, we will try to understand summary measures of this sampling. What are the summary measures? We already calculated summary measures for population, isn't it? Now, summary measures of sampling distribution. How many samples do we have? We have 16 samples. There are 16 samples. This is what is the first sample mean? 18. What is the second sample mean? 19. What is the third sample mean? 21. What is the last sample mean? 24. Just refer previous slide. Just see this one. This I am calculating mean and standard deviation for these numbers 18, 19, 20, 21, 19, 20. For this sample means there are 16 sample means. For those 16 sample means I am calculating mean and standard deviation, isn't it? How many samples are there? There are 16 samples. For sample means I am calculating mean. That is E of x bar. X bar means sample means, E means first expectation means only. How many numbers? There are 16 sample means. For those 16 sample means I am calculating mean, I am getting 21. But it is equal to population mean. Just we calculated in first, initially we calculated mu equal to 21. Anyway, we will compare. In similar manner, I calculated standard deviation for my sample means. How many sample means are there? There are 16 sample means. I am getting 1.58. Just go back and compare these values with the population values. Just see here. This is the comparison between your population and sample. This is my population. For this mean I already calculated 21. For standard deviation also calculated, we calculated 2.236. Whereas for sample, if I take sample of size 2, I calculated sample mean. Here sample mean mu of x bar equal to population mean. They are same. But there is a difference between standard deviation. Standard deviation is decreasing if I take sample of size 2, and of course your original population is following uniform distribution, whereas if you collect samples of size 2 and if you calculate mean and if you plot them, you are getting what you are getting. You are getting I can say you are getting normal distribution, isn't it? This is sampling distribution. If I take samples and if I plot them, how it looks like, that's what sampling distribution says. Let me consider one more simple example. Consider another example that there is a population which following an exponential distribution. Is it not exponential distribution? I already discussed what is exponential distribution in previous classes. It's an exponential distribution. Now, from this exponential distribution, we are going to select 2 at a time. That is sample size 2 with the replacement. When you select 2 at a time, when you find the mean, then if you construct a frequency distribution for sample size 2, we are getting this kind of distribution. Just compare this particular distribution with the previous distribution. Just see, this one is perfectly exponential distribution. What am I doing? I am collecting sample size 2 with replacement and calculating again in similar procedure. If I plot them, just this distribution is we are getting this kind of distribution. You see that parent distribution is exponential. Yes, when sample size 2, if you plot mean of the sample mean, that is following this kind of distribution, somewhat similar to, is it not somewhat similar to uniform distribution? Yes, means distribution is changing. If I take a sample of size 2 with replacement and take calculating mean, and if I plot them, it's just parent distribution is exponential distribution, but somewhat it is uniform distribution. If I increase sample size to 5, isn't it? If I, what's happening? It is changed. Just see this one. When instead of n equal 5, let me say when n is 30, let me increase sample size with replacement. It is looking like a normal distribution. What's happening? Whatever may be the nature of the population, if you select any sample from the population, and if you plot that sample mean, that will follow normal distribution. This observation is very important in understanding central limit theorem. Thank you very much.